All right, let's talk about one of the most powerful technologies out there, something that's quietly shaping pretty much everything we do. It's called machine learning. Think of it like a hidden engine, an invisible force behind all the tech magic you use every single day, from your phone to your favorite streaming service.
I mean, seriously, think about it for a second. How does YouTube do that? How does it know exactly what video you're going to want to watch next? Is it just a lucky guess, or is there something way, way smarter going on behind the scenes?
Well, that's exactly where we're going to start, with all this stuff that really feels like magic in our daily lives. We're about to pull back the curtain on how it all actually works. And trust me, the real story is even cooler than magic. And this so-called magic is literally everywhere. You've got your voice assistants like Siri or Google, right? Your email somehow knowing what's spam. Netflix and Spotify feeding you perfect recommendations. Even your phone recognizing your face to unlock. Now, at first glance, those all seem like totally different things, don't they? But here's the kicker. They're all powered by the exact same core idea. So what is that big idea? It's this really revolutionary concept, learning without programming. This is the secret ingredient, the thing that makes it all possible. So let's break down what that actually means. And here we have it, machine learning. Now, it's a part of the bigger world of artificial intelligence, or AI, but the crucial bit, the phrase you really need to remember, is this one right here. Learn from data. Instead of some human programmer trying to write a bazillion rules for every single possible situation, the machine just looks at the data and, well, it teaches itself.
And this really highlights the difference, doesn't it? The old way you see on the left was all about a programmer trying to think of every single rule. If this happens, then do that. It's super rigid, and honestly, it gets impossibly complicated fast. But the new way, we just give the computer a ton of examples and basically say, here, you go figure out the patterns. Which brings us to the golden rule of machine learning. It's a super simple but powerful idea. The more data you have, the better the learning gets, and the better your results will be. Simple, right? But here's a really important catch. It's not just about more data, it's about good data. Finding and cleaning up that data is actually one of the biggest jobs in this whole field. Because if you feed it garbage data, you're going to get garbage results. Data is the fuel that makes this whole engine run.
Okay, I know this might still sound a little abstract, maybe a bit complicated, but the basic process, you can actually boil it all down to a simple 4-step recipe. Seriously, once you see how it works, you'll realize anyone can grasp the core concept. So to make this crystal clear, let's use a classic internet example, because, cats. Our goal is simple. Let's teach a computer how to find cats in photos. All right, here's our 4-step recipe. Step 1, we need the data, right? The fuel. So we gather thousands, maybe even millions of photos that are all labeled cat. Step 2 is the training. We feed all these photos to our computer model and just let it analyze them. It starts looking for common patterns, things like whiskers, pointy ears, fur. Then, step 3 is testing. This is crucial. We show it brand new photos it's never seen before and check how accurate it is. And finally, step 4, if it passes the test, it's ready to make predictions. We can ask it about any photo in the world, is this a cat? And boom, just like that, the machine has learned. We didn't have to write a single line of code that says, if it has whiskers, then it's a cat. Nope. It figured all of that out on its own. And now it can apply that knowledge to any new photo it sees, all by itself. That, right there, is the incredible power of machine learning.
Okay, so not all learning is created equal. Just like we humans learn in different ways, machines have different methods too. You can kind of think of them as, 3 flavors of learning, and each one is perfect for a different kind of job.
So let's break down these 3 main types. First up, we've got supervised learning. The best way to think about this is like studying with flashcards. The data is all labeled with the right answers. This is exactly how your email filter learns to spot spam. Then you've got unsupervised learning. Now here, the data has no labels. The machine is more like a detective just trying to find hidden patterns all on its own. This is awesome for things like grouping customers with similar buying habits. And last but not least, we have reinforcement learning. This is all about trial and error. The machine gets rewards for success, kind of like teaching a dog a new trick. This is the secret sauce behind those 8 eyes that can master incredibly complex games like chess.
So we've seen how it works. We've seen the different types. But why does any of this matter? Well,
Because this isn't just some clever programming trick. This is the engine that is fundamentally changing, well, just about everything. I mean, the impact is just massive. It automates all those boring, repetitive tasks, which frees us humans up to be more creative. It helps us make way better data-driven decisions in pretty much every field, from business to medicine. It can discover these incredible insights buried in huge piles of data that no person could ever hope to sort through. And ultimately, what it's doing is building smarter, more efficient, and genuinely helpful technology right into the fabric of our daily lives.
So, if there's one thing to take away from all this, it's this. When you hear people talking about the AI revolution, I want you to remember what you've learned here. Machine learning isn't just a part of that revolution. It is the fundamental engine that's powering the whole thing. And the craziest part? This engine is really just getting warmed up. The possibilities are expanding every single day, which leaves all of us with a really fascinating question to think about. Now that we know how to teach machines to learn almost anything, what on earth are we going to teach them to do next?